Choosing between prompting RAG, fine-tuning, and traditional ML is rarely about which one is best. It is about constraints. In this section, we'll use a practical trade-off matrix to match each approach to freshness, privacy, latency, cost, and maintenance. So far, we've moved from the basic distinctions between ML and LLMs into context challenges like hallucination, freshness, and personalization. We then introduced RAG, embeddings, and fine-tuning as solution patterns. Now we shift from knowing the options to choosing among them under real product constraints. Before choosing a tool, diagnose the problem. If you are predicting a number, class, risk, rank, or trend from structured data, traditional ML is usually the cleanest fit. If you need broad language reasoning, start with prompting. If the answer depends on current or internal knowledge, add RAG. If you need consistent behavior, a specific style, or better performance on a repeated task, consider fine-tuning. The architecture should follow the problem, not the hype. A context strategy is not just about which model scores highest. First, look at how quickly the knowledge changes. Then check data sensitivity. Can information leave your environment? After that, weigh operational constraints like cost, traffic, latency, and maintenance. Finally, define quality needs: accuracy, consistency, explainability, and control. The best architecture is the one that balances these dimensions for your actual use case. Freshness is often the first filter. If facts shift hourly or weekly, like prices, policies, tickets, or product details, RAG is usually safer because you update the source, not the model. If the knowledge is stable and you need consistent behavior, fine-tuning becomes more attractive. For broad general tasks, a prompt-only model may be enough. And when updates are numeric, transactional, or tabular, use databases or traditional ML rather than forcing everything through language generation. Data sensitivity can override the architecture you would choose on technical grounds alone. If you use RAG with confidential documents, indexing must be encrypted, access controlled, and permission-aware at retrieval time. If you fine-tune on private data, removal and retention become serious concerns. Even prompt-only API calls may be blocked if user data leaves approved systems. In highly regulated settings, traditional ML inside enterprise infrastructure may be the safer, compliant choice. Cost and latency often look fine in a prototype, then change quickly as traffic grows. A prompt-only system is fast to launch, but large prompts can make every request expensive. RAG adds retrieval, ranking, and context assembly, which may improve quality while adding delay. Fine-tuning can reduce prompt size by moving some behavior into the model, but it also adds training and deployment work. For repeated structured predictions at high volume, traditional ML can be the most efficient option. Accuracy is not one universal standard. A support bot needs answers grounded in trusted sources. With citations, users can verify. A classifier needs measurable precision, recall, and labeled test data. A brand assistant needs reliable tone, structure, and format. Choose the method that matches the kind of control you need: RAG for factual grounding, fine-tuning for behavior, and traditional ML for measurable prediction. Evaluation should mirror the actual goal. A trade-off matrix turns architecture debate into shared evaluation. Instead of asking which approach is best, ask best against which constraints. Score each option for freshness, privacy, latency, cost, control, maintenance, and data needs. Include business realities alongside technical ones. The goal is not mathematical perfection, it is clarity. As requirements shift, revisit the scores, because the right architecture today may not be the right one later. Imagine an employee asks, "What's the current parental leave policy?" A prompt-only model may answer confidently from outdated assumptions. RAG is a better primary choice because it pulls the latest HR or security document, uses that context, and returns citations. Fine-tuning can still help later with tone, templates, or escalation behavior, but not with fast-changing knowledge. Fraud scoring is a classic case where traditional machine learning is the right core architecture. Transactions become structured features. The model compares them against patterns learned from labeled history, and the output is a fast risk score that drives approve, block, or review decisions. RAG adds little because there is no text knowledge to retrieve in the critical path. LLMs may help analysts explain cases, but the scoring engine should stay optimized, measurable, and low latency. Customer support is a strong hybrid example. Fine-tuning teaches the model how the brand sounds: friendly, formal, concise, apologetic, and clear about escalation. RAG supplies what should not be memorized: current policies, account status, product details, or VIP rules. That avoids retraining every time facts change. The result is a consistent draft grounded in up-to-date information. Strong AI systems usually grow in stages. Start with prompt-only workflows when you are prototyping, testing value, or handling low-risk tasks. Add RAG when answers need current, private, or domain-specific facts. Introduce fine-tuning after you see repeated patterns that need better consistency, tone, format, or task performance. Use traditional ML where structured prediction, ranking, routing, detection, or optimization matters. The key is intentional complexity, added when a clear trigger appears. Before you commit, pressure test the choice against the real failure mode. Use RAG when the gap is current or private knowledge. Use fine-tuning when the gap is consistent behavior or task quality. Use traditional ML when the data is structured and success is measurable. Avoid fine-tuning facts, using RAG for simple classification, or calling an LLM when SQL is enough. Start simple, then add complexity only when requirements demand it. Remember, architecture choice is a constraints decision. Use RAG for fresh knowledge, fine-tuning for reliable behavior, traditional ML for structured prediction, and prompting when the task is simple enough. In practice, strong products often combine these pieces. Next, we'll apply this framework to design a context-aware LLM feature.